So we have a few students who are expressing concerns with how to write a piecewise function, especially when you're looking at something that is quadratic. So what I did here is I grabbed from the learning activity, question 5C. I took the question out of there, I drew it on the board, and we're going to work through this one together, and we will make the piecewise for this equation. A couple things we need to realize, of course, is yes, this is a quadratic equation. Yes, the original vertex is at -1 and -4. This is going to be an absolute value, so it's going to get reflected above. So the easiest and best way to start a question like this to come up with the piecewise is always going to be what was the original equation, and then we can make it an absolute value equation, and that's going to make our lives way easier. So the first thing we're going to do here is a quick review on how do we create an equation for this using quadratic formula. So for the original equation, where that does fall below, the vertex falls below the x-axis, I'm going to use the y equals a times x minus h squared plus k quadratic formula, so vertex form, and all I got to do is plug in now with my vertex at -1, -4, I can plug these values in for my h and my k values. So y equals a times x plus 1, because it's minus a -1 squared, minus 4. I have the start of the equation. I don't have the a value. I can get that a value, of course, by just taking any point that exists on this function, and I can substitute it in at the y and x location there. So I have two possibilities that are given at this point. I have -5, 0, and I have 3, 0. So I can use either one of these points to solve what my a value would be. I like working with positives, so I'm going to use 0.30, and I'm going to substitute those x and y values in here. So 0 equals a times 3 plus 1 squared minus 4. Solve for a. So this is going to become 4 is equal to a times 4 squared. 4 is equal to 16a. Therefore, a is going to be equal to 4/16 or 1/4. Now I have my final equation for the original. Again, I keep saying the original. Y equals 1/4 x plus 1 squared minus 4. There. That is going to help me create the piecewise. I am going to create some room here. So now I got to look at, this is an absolute value equation. There's my absolute value brackets. Now the piecewise I can build from this. I can turn this into, so y is going to equal, there's going to be 3 pieces here, right? So from -5 and less, it was naturally above. From 3 and greater, it was naturally above, but I did have to find the reflection from -5 to 3, and that's just going to be my pieces. So the first piece is y is equal to the 1/4 x plus 1 squared minus 4 when x is less than or equal to -5. Right? I'm also going to have, I'm going to skip and make a little one here. X is going to be, y is going to equal 1/4 x plus 1 squared minus 4 when x is greater than or equal to 3. Those are the two pieces. Now, the only piece I got to account for is the one that did get reflected in the middle of this. All I got to do then is say I need the negative, right? So negative in brackets 1/4 x plus 1 squared minus 4, close the brackets, when x is anywhere from -3 to 5, or -5 to 3, sorry, so -5 is less than x, which is less than 3. And just like that, I have the piecewise for this particular function, and it was way easier to get this built once I had the original function. So that's why, if you're asking why am I asking for that one, that is why I'm doing so. I hope this video helps. Please continue giving it your best shot.